Yep, that sounds good.
All right, cool. Well, welcome everyone to the April 2024 Kubernetes Atlanta Meetup. My name's Joe Searcy. I'm here with Nate Lee. We'll be your co-host driving this bus today. As usual, we start off with a little bit of what's going on in the Kubernetes community, news and the project itself and other things going on in the ecosystem. So first up, we're sort of in between Kubernetes release cycles right now. 1.30 just released within the past couple weeks, and the 1.31 release cycle should start by the end of this month. So within the next few days is what it's scheduled for right now. So no current deadlines for enhancement freeze or anything like that. But if you've got KEPs and things like that you're working on, be prepared to dot all your I's and cross all your T's to get ready for that. So yeah, we did have the version 1.30.0 release of Kubernetes. I believe the code name for it is Kubernetes for any anime fans and stuff out there. But kind of a big thing. Along with this, we had KubeCon EU last month as well. And with that, kind of celebrating 10 years of Kubernetes, the Kubernetes project itself. So kind of a big milestone for the project. It's been really cool to watch it evolve over the years and see where it started and where we are now. We did also have some fixed releases for 1.29.4, 128.9, and 127.13. Reading through the release notes, I didn't see anything like super major there to call out, but know that it's out there. Those are the versions. If you're not on there or near them, consider upgrading and get to it. Again, here in this section, we got promotions, deprecations, CVEs, PRs of note. If there's an NA there, it doesn't mean that there weren't any deprecations or CVEs or PRs of note, just nothing huge to call out. But a couple things in the promotions and a KEP that has kind of graduated. We have the CRD validation with Cell. That moves to stable. So if you're not aware, I'll just do a quick little overview of this. This is essentially taking the existing CRD definitions where you had some minor validation syntax that you could add through the CRD configuration itself, as well as the Open API validations. This enhances it to where you can do a lot more complex logic since I want to say like 2 years ago, the project started incorporating the Cell language for different types of validations in different places. So this is just extending that and stabilizing it so you can do more complex validations inside the Kubernetes API server versus having to have a custom admission controller or something like that.
This is with 130 release?
Yes. Okay. And then container resource-based auto-scaling. So this is an interesting one. So in Kubernetes world, we typically have a pod as like the smallest unit that we deal with. And the existing horizontal pod autoscaler scales based off resource usage of all containers within a pod. But if you say you have like a sidecar or multiple containers within your pod, and some of them you don't necessarily care about their utilization, and you don't want to scale based off that. This extends the logic to actually go to a per container resource usage model for horizontal pod autoscaler. So kind of interesting thing, just gives us a little bit more flexibility, especially as I'm seeing a lot more workloads or talking to people that with a lot more workloads that are running multiple containers. We'll talk about one use case in just a second. But so moving on to the community news, there were a few projects that caught my eye over the past month and a half or so, one of them being Open Unison here. And this is a project, I'm not going to dive deep into it, but if you've worked in and around Kubernetes for a while, you've probably run into like, how do we authenticate and log into a cluster? How do we get a kube config file to be able to do our jobs like day to day? And especially if you're in an environment where you have like dozens or hundreds of Kubernetes clusters, like that can kind of become a pain. Or if you're running certain applications on top of Kubernetes that have integration to like the Kubernetes API server for RBAC and things like that. So like the Kubernetes dashboard comes to mind, things like Kiali if you're running like a Istio service mesh scenario. This project provides integration at the cluster level and sort of at the client level with like kubectl and some of the other tooling. They have different plugins and stuff like that, but essentially it gives you kind of, no matter where you're running your cluster, it gives you the ability to kind of have single sign-on, which is pretty cool. And then kubectl sidecar. So this is a great example of like when you might be running multiple containers. This is a project, if you've been around the Kubernetes community for a while, you should know who Tim Hawken is. If not, he's one of the people that's been there from day one almost. And he's a big, influential maintainer in the community. But he put together this kind of model as an example of Kubernetes has, sometimes when you're running a workload in Kubernetes, you want to have sort of introspective information about the cluster or the pod that the application is running in. And the Kubernetes project itself did implemented some of this through what's called the downward API, where you get things like your pod name, your pod IP, different things like that. But sometimes there's other information that you want, and it can kind of be a pain to get. But this model essentially runs an extra container within your pod, and has a little bit of configuration that you can define what type of information you want to get, and it exposes it via an internal like web server essentially. So you can curl localhost or read from localhost and have that information be exposed in a JSON format, which is pretty slick.
So it's like a container metadata service?
Yeah, exactly. Like if you run like a lot of the major cloud providers have something similar to this. I'm most familiar with like DigitalOcean, where you can kind of curl like localhost metadata or whatever their endpoint is and get information about the droplet you're running on, the VM you're running on, and different things like that. So kind of an extension of that. Another project that was interesting, and I honestly didn't read a whole lot into this, but the concept is very interesting. We've seen some stuff in the past, but this is from Rancher. It's called K3K, kind of building on like their K3s branding and stuff like that. But we've seen some stuff around like virtual clusters and like clusters within clusters in different ways. And the implementation models of some of the other tools, like vCluster, is very different from what K3K is here. But yeah, again, you can kind of just, have your inception Kubernetes, all the levels that you want. But rather than doing kind of shadow resources where you have like a separate API, but the controllers create the pod resource, service resources, and the underlying kind of host cluster, this is like kind of even more separate degrees of separation there and isolation. So pretty interesting, and they have it all through, like bundled up through like a CLI and stuff like that. But pretty interesting. If you're doing any type of intricate testing, or you're in an environment where you need extreme isolation between cluster environments, but you want to keep your actual footprint small of like what you have to maintain, could be a really interesting project for you. And then again, getting into, I've got a bunch of Kubernetes clusters. Oh no, what do I do? Microsoft and the team behind the Azure platform has this Fleet project that basically gives you some multi-cluster orchestration, wrangling, and things like that, and in a kind of hub and spoke design. And again, I'm not going to go into a lot of detail. If you remember way back in the day, if you've been around the cloud native community for a while and remember CoreOS's Fleet, like there's definitely some things borrowed from there, as well as a couple other projects out there that give you kind of a multi-cluster control plane for an entire fleet of clusters. And that's kind of all I wanted to go through right now. For those in the room and those on the call, if anybody's hiring, if you're in the room, sync up with me later. If you're on the call, please post in chat. If you're hiring for any positions, please include your name, contact information, position, title, and description, and we'll get those added to the Meetup notes as well. And then before we kick off, kind of normal thanks and gratitude towards Georgia Tech ATDC for hosting us here, to Calendly for supplying our Zoom webinar information, and to SpeedScale for all sorts of stuff that they do to help us out here. So with that being said, I'm going to turn things over to Jim, who joins us from Dagger.
We're all good. You can hear me okay?
Yep.
Okay,
Well,
great.
we can.
Get a thumbs up on the call too.
They say they can.
Okay, awesome. Hi, I'm Jen. I am a product manager at Dagger. I'm going to be talking about Dagger. First what I'm going to do is, I've got a slide deck, but I've got a couple demos too. It's always important for me to show the tech. But the intro will be more of like overview of what Dagger is, more of the benefits of it, and then we'll get into 2 demos that will show how to use Dagger to run locally and then like a potential production architecture too. So, so Dagger is a CI, sorry, there's people walking into the room now. Let's come on in. Oh, yeah, that would be helpful. Okay. Yeah, so there's my intro slide. So Jen Allen, product manager from Dagger. So Dagger is a way to write your CI workflows as code. So rather than writing a bunch of YAML or custom configs in different languages like Ruby script, you're writing a composable, reusable pipeline that runs in containers and runs the same everywhere. It's not replacing CI, it is your actual workflow, it's all the logic, and it's, as I said, it's written as code. The Dagger platform includes multiple pieces. One part is the Dagger engine, that's where actually all the logic is, and that's what it's executed. It runs all of your pipeline in containers, so CI containers, or for instance, if I'm running locally, I'll run Docker desktop, so it's in Docker containers. There's SDKs, so you can write your pipelines in the language that you feel most comfortable in, which helps bring the CI to the developers and make you feel more comfortable and make it a lot easier for you to debug because you can check this in as code. And the 3 primary SDKs that we have now, and the community is adding more all the time, there's TypeScript, Go, and Python. There's also a .NET SDK in progress that the community is working on, and a Java SDK. So there's more coming all the time. And then one place we'll get down in a little bit is talking about the concept of Dagger functions and the ability to reuse functions across your pipelines and also across the community. Okay, well, there you go, standardized functions. So what I have here is a screenshot of an example Dagger module. So a Dagger module is a container, essentially, like it's a Git repo. Right now we support GitHub, but we're adding more repositories and sources soon. And it's where you just store your source code because your Dagger module and functions are all code. What this brings to you is that you're able to chain these functions from other modules with yours. So it doesn't matter if this module, Vercel, is written, say it's written in Go, and you're writing in Python, you can call this module from your code, and we have Python examples for you to use, even though it's a Go module, because we're doing code gen at the base level. So you end up with this really super extensible API. And so what this graphic is trying to show is that when I'm contributing code, before using Dagger, before I joined Dagger, you contribute code, and you wouldn't know if you pushed it to CI. Your PR, you push your commit, is it going to actually break CI? And sometimes it's really silly. When I was first starting to contribute code, I was like, oh, I didn't run prettier, so it was a linter issue and I broke the build, or I didn't break the build, but I broke that. And so that meant CI ran, we did all those cycles, and it just, to me, it really started to slow things down. So in this case with Dagger, what you run in CI, it's the code, you can run it locally. So I don't have even the production infrastructure, the way you run it or where you run it is different, but what you run is the same. So you can spin up services, you can have a container and host networking, you can do everything that you need to do in a production environment on your laptop. So this quote, eliminate, push, and pray, comes from one of our community members and customers. And we're just it made a lot of sense. So it's just okay, is it gonna break or not? So.
We call it YOLO merge.
YOLO merge. Another awesome benefit of Dagger is that it, because it runs your code, it builds a DAG. So it builds a graph and it knows what has been built, and if something is changed, it's only going to rebuild or re-execute that task if that's changed. So you get a lot of you get an operations cache to start with, but you also have cache volume. So if there are things like in here, you can see I've got a Go build, for instance, with a Node app or you have a bunch of Node packages and dependencies, and you always have to download those, and it takes a lot of time. And there are tools to cache that. But imagine just being able to have that be consistent no matter where you're running your CI. So the volume cache really helps with that too. Sorry, the touch bar is really sensitive. And this is just emphasizing again, showing here that there's multiple languages, so you don't have to worry about rewriting something. If you see it presented from the community, if you see it on GitHub and it's Dagger code, you can use it if it's using Dagger functions. So. And then finally, we have Dagger Cloud is our visualization system that provides history and context, and it lets you visualize your runs that happen from your local dev machine and in CI and across any CI. So one thing I didn't call out earlier is because Dagger we're CI agnostic and we're architecture and infra agnostic. We're not hosting your infrastructure for you. From a company perspective, we are very heavily involved in open source. We create the project and maintain it, and we really foster it with the community. And then on what we're providing is a lot of we are always constantly in the Discord helping people. So if you are interested, I really recommend connecting to our Discord. But the visualization is a way to have a persistent history across your team. So this is a new UI that I will show shortly. This is a view called Traces. And it's really helpful right now for debugging. Something goes wrong, why? Is it because I failed? Did I not run Dagger locally, or did I run it locally and I didn't do did my linting fail? Or is there something flaky in CI? Is an external service potentially being problematic? Is CI itself down, which we've seen recently too? Okay, so then a call to action for the community, but I want to get into the demo. Before then, were there any questions that came up so far?
Not so far, in the chat at least.
So for running it locally, what is the requirement? Because I'm working with a team right now, and there's Intel Macs, there's ARM64 Macs, there's Windows, can I just say use Dagger and all those folks will kind of be able to just go?
Yeah, we have there are so I'm on an Apple Silicon M2 Mac here. We have people running different flavors of Linux. Then there's M1, there's Intel Silicon, there's Windows. People running Windows with Wine. Yeah, it's just going to work. So we're working on getting more official packages for the different package managers too. But yeah, it's infra and it's architecture agnostic. Yeah. Basically, if it can run Linux, it can run, if it could run Linux, it could run Dagger. Yeah. There's a discussion that we have can it run Dagger? Just can your watch run Dagger? So, yeah. Okay, so I'm going to give two demos. I'll start with a demo of how to use Dagger functions from the CLI. And I'm going to show kind of a funny one first, actually. Do you guys know K8s? Yeah? Okay. So we're going to do something like K8s, but this is the Daggerverse, as I was saying, where this is where modules are being contributed. This is an index. This is not a registry. So all of this these are GitHub. I said eventually we'll have GitLab and other sources, but go down here, there's Pony-say. And so this documentation, if I go into the, let's open the source code, and we can see here that I've got the Pony-say, I'm in the Purple Clay Daggerverse Pony-say directory of their repo, and they have their code here, and you can see there's a bunch of quotes, so that's a little bit of a preview. But if we go in, you can see that there's these comments. And these comments are the way that you document your functions so that when they show up in Daggerverse, that someone knows how to use them. So we auto-generate this documentation. So if I go down, I say, okay, you can see the description here. Cows talking, that's so last week. Ponies talking, well, that is so today. So let's try running this. So here's down an example. You can see that we've got a couple different functions. We have say and we have inspire me. So let's do say. So if I go to the shell, like I can just copy this, and then I can go to, actually I realize this, it's not sharing. Is it sharing the second desktop now? Do you see VS Code?
Mm-hmm.
Okay, awesome.
That TV will show you what you're seeing.
Thank you so much. Okay, so now I can just run this. And the pony says Dagger's awesome. So let's go over back and say, let's do the inspire me. And you can see here, this is like if you wanted to use it within your module from code, this is how you would use it for Go, Python, and TypeScript. But shell is cool because it's showing you, I have Dagger installed locally, I've got Docker desktop, and that's all I have to do to like use this module, and I can chain them via a CLI call together as well. So it's pretty powerful. Let's just say hi to that pony. Let's do this. So we're gonna get inspired. So what's happening here is that it's spinning up a container in the background and executing that code, and then it returns it to you here in the terminal. So that is a very inspiring quote. Okay. So I'm going to go back to the what I've tried to do too for people who aren't able to attend today and after the fact is that I've tried to put as much of the demo script into this deck so that people can follow along later. So I'm going to just cover really quickly the 101 architecture. I did a little bit of this as we were talking, or as I was talking earlier. But Dagger is comprised of a CLI, SDK, and an engine. And you use Dagger call via the CLI to run Dagger functions. And you can also use those Dagger functions within code to execute them. These Dagger functions ought to be written, I said, Python, Go, and TypeScript. And yeah, I don't need to repeat the fact that the last thing I said there was that you can reuse them. What we're going to do is look at an example project that one of my colleagues created. It's a Go application created by Kyle Penfound. It's a simple app with a Go backend API that returns, that takes a query, returns a simple message, and then a Hugo front-end static site generator for it. So what we've done to prepare for this demo is that we cloned Kyle's project locally. And then what I'm going to show in just a moment is that we'll look at the backend code quickly, and then we'll see that the backend is in the main.go, and then we'll look at see the front end, and we will then also see how the CI works. So let's see. Okay, so I'm here in Kyle's Greetings API project, and he's kindly, I've also included the link to this project within the slides. He's kindly created a demo flow, so you guys can also follow this separately if you like. And so in here, we've got the main.go that is the backend. This is the API where we're setting up the server, and so this is where all the backend work is done. We've got the website, that's just where all the Hugo configuration is. And we also have this CI file. And so the CI is where he's written all of his Dagger code, his Dagger pipelines. So we've got testing for the back end, or we have workflows for the back end and for the front end. And if I were to go in here, we've created like this concept of submodules. So it's like you have a pipeline module essentially, like just as a rough terminology. And then these submodules that say like, okay, I want to run CI, and in CI, I need to do backend, I need to do front end. So you can start to see, and then within backend, it's calling other functions. So you can see a lot more about how the composability is, so that you can't stick everything within one module, and you can also use it and compose it, one module that calls out to multiple as well. So within, let's go to the main.go where this is the overall module that runs CI. So we
just like a hair bigger.
Yeah, sure, no problem. So we can see here in the code, we see test, we see lint, we see build. I'm like, okay, I start to see this is Go code. I can start to follow what's happening and seeing where here we're creating a, let's see here. We're setting up the result, we're creating a container, specifying a directory, and then providing that so that you can say what directory you want to use to run the test. But really, like the easiest way to consume this, if you're going to do this, is very through this function by running Dagger functions. And so what this does is it spins up Dagger. It looks at the actual, all the modules and functions. It composes the combined API, and then it spits out the help. So this is all inline comments from that's treated as inline documentation for you in the CLI. So including if I called multiple and changed multiple modules in the CLI, it would give me the help for that. So if I wanted to do, so in order to call a specific function, I say Dagger call. And let's say I want to see test, and I want to see, like, I want help for test. And so we'll run that. And now I can see, well, how do I use test? So, okay, here at Dagger call test, it requires a directory, and there are other things that I can do, like, oh, I want debug so I can get heavier logs, right? So let's do a call. Let's actually run CI. Dagger call test, dir, and we're going to run it in the root because we want to run there. So we can see it spinning up here, and it's running tests, and I can also, you can see it's now, you can see the steps, but it happened very quickly, right? You can see the test passed. Now I can go in and see here what happened. So this is the test results. And sorry, the Wi-Fi is a little slow for me. So you can see I have the test results here. This is the Dagger cloud UI set. So I ran this locally. I have an environment variable set. We're adding a really awesome seamless login experience soon. So you can see here, these are all the different steps that happened. And if I hover over these various pieces, like you can see here, the actual call or all the metadata that happened is a part of the step that was dependent of that. And if I click in, I'm then taken down to that. So here, nothing failed. It's super useful to see how things are happening. Look at, oh, why did this thing take a long time? As you're building your CI, this is a useful view. But it's especially useful when something fails. And I have an example here, like this is a very kind of silly input, like how say yo standard or intentionally trying to break things. But you can see here, this is clearly telling me that something's broken. I can see the errors. I can see like what was the origination of that, and then I can click into it, and it'll take me, say, to that error, where I can see the error logs there. So this is a pretty new UI for us, this particular view, and we're continuing to make improvements to it. So if you guys have feedback, I'd love to hear it.
I got a question.
Yeah.
In this case, what was the fail error like? What is this actually saying that actually failed? Is it saying connection failed or?
Oh, I think that this was like, I think someone canceled this one. This isn't a good example. I just grabbed one quickly. Yeah. I can give you a better example later. Yeah.
So that's on the web somewhere?
Yeah, it's
effectively?
Yeah, it's dagger.cloud. We have a free plan. So for an individual, one person, like you're working with Dagger, it's free. If you're a team, it's $50 a month, and it's a team of 10. So, and our goal is just like make it super easy for you to use Dagger. We have an experimental distributed cache that comes with the team plan, but it is experimental. So mostly visualization is the primary place that we're looking to invest. And and as the product manager, I'm looking to hear more about the types of visualizations and use cases that you might have that would be really important. For instance, if you wanted to see any form of analytics and like, what would that mean? Obviously, you're all probably new to Dagger, so I might be asking too much right now. Okay, so let's go back over to our code. So I just ran Kyle's CI. I ran the test workflow. I wanted to show one more thing here. If I run Dagger functions again, I can see the help. And yeah, our Wi-Fi is being a little bit, there we go, okay. So you can see there's a serve command. And so This one I was saying earlier, that you can spin up containers that will then that will allow you to also specify like ports and like network connections. So this lets you do a full spin up the back end and front end, so that includes Hugo and being able to then have the back end and front end talk to each other, which is super cool. Okay, so let's go back to our deck, to the presentation. And
So I got a quick question, Jen. So once the build has been completed, do you have the ability to generate a bill of materials if you need that for your project?
like a
An
build.
SBOM in whatever format you may be looking for?
We're working, that is something that's really wanted in the community. Like you can do it, but it's not like a first class artifact. Yeah. So you can with the containers, like the default when you just like build a container is like you built a container, right? And then you can do the output where you actually then like say push the container somewhere. What we don't have right now in like fully integrated platform is like, okay, what was the full attestation of everything that happened within that workflow, right? Like some sort of artifact that comes out of it.
Okay.
Yeah, so we'd love to like, if it's something you're interested in, like we're open source, we'd love to hear about that for sure, get your help with it. Okay, so we did that example. So we ran the CI for the Greetings API. And this is just for people later if they want to see an example of what that looked like. Do I have enough time to do another demo? Okay, so I wanted to show, I'm here at the Kubernetes meetup, just show something Kubernetes. So I wanted to show, I had not myself worked with Tecton pipelines before. And I have some experience before working in CI. I worked with Jenkins and I was working on like early days Tecton many years ago, but had never worked. Tecton pipelines were just starting to be a thing. So that was a good opportunity for me to learn more about them. So this is overall going to be a little repetitive what we talked about, like why locally testing matters. But one of the benefits of what this demo is going to show you is that the architecture is not that different between like, the only difference really is the architecture. Like I'm going to be using kind with Tecton pipelines, and then the difference is you can take that same Dagger code in the basic configuration and run that the same in production, right? So this is from perspective of also reducing the amount of YAML that you'll need to write. Now, reducing the YAML isn't the primary objective only of Dagger, but it is a big side effect or benefit. And it's also like, because it is code, you can check it into source code that developers can understand what's going on as well. So this is a very rough, very ugly diagram, but so we're gonna have like, I have this already set up. So I've already set up a kind cluster running on my dev machine. We're gonna have the Dagger engine is gonna be executing within there along with Tecton pipelines. We're gonna, from our CLI, my CLI, I'm going to call Dagger, or we're going to not call Dagger, we're going to call the Tecton pipeline, and it is going to call Dagger. So I'll show you what that actually looks like in the YAML config in a second. So I have some links here to, this is the demo project that I created for this. I created a README that includes all these steps too as well. And then we also have a doc for integrating with Tecton, which is basically the same config, but on the Dagger website. So let's see here. Is there anything? Yeah, the one optional piece too, which is in the doc that I shared in the project, is how to create a secret for the Dagger Cloud token if you wanted to use Dagger Cloud and send visualization to it. So, okay. Let's go to VS Code. So I'm going to go to my other window, and this is where I have my project. So I have the Git pipeline, and so this is where we have like the parameters set for the Dagger Cloud token. Let's see, have also specified to use Kyle's source code repository as what we're actually going to run against. And so that's the repo URL. And then we have here the definition of we're going to install Dagger here. And this is where we're saying and this is the path, and then we're saying this is the command we're going to run. This is the exact same command that we ran locally on just a minute ago, right, with Docker desktop, basically. So the command that I what I'll need to do is run, we'll do a call in Cube. So I'm going to run git pipeline. That's going to call Tecton pipeline, and we'll run that. And then I'm going to get, I want to actually follow and track the log. So I'll get to the end, and I'm going to grab the ID here so I can see the log output happening in real time. So it's already spun up the container, and it's already spun up in kind, and it's doing all the work. And now I can start seeing this come through. So I can see this is all of the worker, like to get and clone the repo, because we said, hey, we want to test this repo, so we're testing it. Keep in mind, this is a little slow because it's running kind on my machine and doing all this work, right? And then you see Dagger is doing this. So that was all the prefetch work, and now Dagger is starting to do the execution of building the container so it can do the test. And then it'll have like steps at the end where you'll see Dagger, I think, :engine, and that's where it's like the engine doing its cleanup at the end. So this is really helpful. It's a lot of raw logs, but similarly, I can see the same view within Dagger Clouds. If I go back over there, we can see if I go to my organization over here, you can see it's running actively now. We have a bug right now where the duration is showing up much longer than it actually is. So this is accurate. It's reported we're working on this, but you say, oh, there's nothing interesting here. Well, part of it is because like a lot of the actual underlying work to be able to run the test is happening. So if you expand that, you can start to see all the different, like this is a DAG of what's happening within your pipeline, and the real time, you can see things like the real-time execution of what's happening in there. So this is all streaming. And so yeah, that is, I can show you an example of what it looks like when it's done. So if we do this one here. This is an example, so we saw earlier, from the code, essentially the output that you see as far as like what actually executed, it's the same. So you'd be like, oh, did I run this locally or not? You'll notice we don't have enough metadata in our UI right now. We're working on that. Like, did what VCS, did it come from what CI, who did it? That stuff's coming, but it is really interesting to be like, oh wait, now these things are so similar, like where is it actually coming from? And I think that I'm pretty close here to wrapping up, so just thanks for your time here. Let's see. Yep, example output. So yeah, okay, well, what would it look like to run this in production? It's like, oh yeah, cool demo, but do I have to redo all of this if I want to use it in CI? Like, no, you don't. This is really, really rough architecture, like maybe it's GKE and you're using, you have your Kubernetes cluster running there. The difference is you've got here, instead of with kind, I've got I've got Tecton triggers. So like maybe I set up for GitHub, I set up a webhook so that it then calls Tecton triggers so that it knows like an action happened where I pushed my code to I merged a commit into a PR, and now it needs to run CI, right? So then it's going to go and execute all of that. But all of the Dagger code is the same. So that is one of the big benefits. If you wanted to have different logic within, you could, but you don't have to. So yeah, that is pretty much it. We already did the pony say, and here's our Dagger Discord. And if there's anything else any questions you have, let me know. If anything later, I'm here too.
One or a couple questions. One is if I'm writing custom like functions or modules, do they have to be hosted in the Daggerverse?
No,
or
they're not hosted in Daggerverse.
Okay.
We're just an index.
Okay, all right.
Yeah, the way it works is that if a function, if it's public, like if it's in a public GitHub repo, or right now it's GitHub, but we'll have more soon, support for more soon. It's like Go packages. It's like the Go package index. It works the same way. So, we plan to eventually have, or we're thinking about like, oh, you might want to have some sort of identity and like be able to say, oh, these are my modules. But right now, and regardless, we're always going to have an open index. So our goal is not to like wall it off.
Okay. And then going back to like the SBOM problem case, like that's something like I could build a custom module that does that and use that there versus you're talking about like potentially making it a kind of first party like function or whatever.
Well, I think it would be a module regardless. Yeah. And then there's like a lot of people in the ecosystem and like some partners that have been really, we've got Trivy module, we've got a bunch of different Chain Guard has been really interested in working with Dagger too. So I think there will be seeing a lot of really cool stuff coming out and showing up in the Daggerverse.
Awesome.
It's also just not my area of expertise when it comes to like how you would build that. So, but yeah, definitely like the people that built started Dagger were the early founders or co-founders of Docker. So Solomon Hykes is our CEO, and then the people, pretty much everybody who works at Dagger has been really heavily involved previously in the open source community. So if you have questions, if you're on the Discord, they will be right there helping to answer them. So thank you so much for your time.
Thank you.
Should I leave my laptop here or should I leave the room?
You can take it.
Okay.
Yeah.
All right, you ready?
Give me 1 second.
Yeah, okay.
He's like, hold on, wait. All right, I'm good.
For those on the call, we are gonna take like a 1 minute break here, and we'll get started with the next talk in just a little bit.
You need a charging cable while you're recording.
Mahal asked what your UI is made from.
Oh, the browser UI?
Yeah.
Ours.
Like the Dagger Cloud UI.
Oh, it's a React, it's an XJS app. Yeah, and then the person who did Traces UI is Alex Sirachi, who made Concourse CI. So we're doing a lot of work to try to make the terminal UI and the experience in the cloud like really a lot better together. So the idea is we don't want to make the open source experience should be really, really awesome too.
Just make sure you're muted and your audio is down.
Yeah, I was gonna ask you that, no mic required.
Yeah.
But turn your camera on if you don't mind.
Got it. You made it, see me, and I was going to. Okay, good enough. Alright. That's a lot of stuff on my screen. Alright, let's see if we can get this thing hooked up.
You don't need to do that. You can just share your screen.
That's it.
Then, turn your camera on.
So it's on, okay, good, got it.
Can you turn your camera on? I'm sorry.
Can't see much, but all right. All right, hear me, good? That's okay, great. All right, let's go through here. Okay. So, my name is Matt LeRae. I am CTO and co-founder of SpeedScale, which is no longer sharing on the screen.
I got it.
Oh, yeah, worked, okay, great. All right, so anyway, yeah, so SpeedScale, we are one of the sponsors of our little party here tonight, and I am going to talk to you about some cool open source stuff that you can use to look into your Kubernetes cluster and do all kinds of cool network stuff. Now, who here has used Wireshark before? Anybody? Wireshark, all right, okay, cool. So I'm going to show you the Kubernetes version of Wireshark. Anybody seen this before? It's called KubeShark. Okay, so I'm going to solve a problem that is near and dear to my heart, which is I like to, let me back up a second. I hate doing work. Okay, who here hates doing work? Hate it. So my mission as an engineer for many years now has been to either find a way to do less work or find a way to get other people to do my work. Either one is fine with me. So I like tools that allow me to do that. So one such tool is traffic replay. Okay, so I know Joe knows, because he was telling me about this earlier. Has anyone ever worked at a company that had a traffic mirroring or traffic replay system? No? You have. Oh, can you tell me about it? I don't know. Anyway, you remember? So what is the problem that traffic replay solves? Well, if you're a Kubernetes administrator, the problem Kubernetes traffic replay solves is every time developers push a new version, it's broken and they blame you. So this is your chance to get back at them and to blame them because their app does not work, right? And you're going to do that using the best source of info you can find, which is actual users. So anybody here ever written a test script before? Yes? Okay. I know you have, Ken. Ken, my co-founder, and Nate, my co-founders, yeah, we've written test scripts. Okay, so testing's sort of like dead, right? Like nobody really wants to write testing other than like unit tests, right? Now, I'm not saying that we don't all want to test. I'm just saying it's too hard to do in cloud native for most folks. So what the big companies have done is adopted this idea of traffic replay. I'm going to show you here how to use some cool open source stuff to do like a very easy like validation for new builds that come out. I'll talk a little bit about how to put it in your CI pipeline for the adventurous. It's all in a GitHub repo, and let's get started. So I did this presentation once before. This is probably one of my last traffic replay presentations, because at SpeedScale, we're all about like AI now. And AI tells me that one day I will get to maybe like polish the servers that run the AI, and that's the only work I'm going to get to do. So along those lines, and I think that's great. Again, come back to point one, I don't want to do work. So what I did as well as part of this presentation is I've been playing a lot with AI, and image generation in particular. Now in the AI world, these LLMs, those are large language models that do all the cool ChatGPT stuff. Turns out you could fake them out using something called a RAG, or RAG, which basically means you take these pre-trained models and then you attach new information in a vector database called a RAG. So that's not, you don't have to know anything about that, except that you can fake it out into thinking that I am a llama. So this is the result of such a query. So you will see this throughout the presentation. You can, in fact, fake them out. Okay, so we talked a little about testing. Nobody wants to do testing, but we still want the validation. Okay, so create an image of Matt debugging a production problem on a computer. So we've all been there. This has all been us. Okay, so nobody wants to write tests anymore. Nobody wants to figure out or talk to the application team because they're strange. And so nobody wants to get all that done. So what if we just use production traffic? Okay, so the idea is I want to record some network traffic or however you want to store it. I'll record it from a production environment, Kubernetes cluster, and I will take it back to various other environments. That's the idea. So CI pipeline's the obvious one. Plug us into Dagger, sounds great, awesome. Or bring it down to developer desktop. So in an ideal situation, what you'd be able to do is say, we had a production issue. I want to bring it back to my local developer. Again, I'm not very good at programming, so I'm going to run a debugger on my local desktop and use the production backends. Like that's like the ideal state, right? So step one is just poke the app and see if it works, right? Every time you get a deployment. So then it's not my network, it's not Kubernetes, it's not the infrastructure, it's something else, right? Okay, now, if you've been in the space a long time, which I have, there's been like 3 cracks at this problem of trying to reuse production traffic. So the first one is, who here has heard somebody on Twitter or elsewhere on the internet saying, test and prod, test and prod, test and prod, only test and prod, that's all that matters. Have you ever heard this phrase? Okay, how's it working out for you? It was great, it was a lot of fun, everybody enjoy that? Yeah. It turns out, in order to test and prod, you have 2 choices. Choice number 1 is work at Twitter, Facebook, or Google and have roughly 100 engineers designed to build such a platform for you as a developer. Option number 2 is you can hire Joe, and Joe can tell you about it, right? But we'll get to that in a second. So I definitely recommend testing and prod only because the nice person at the Kubernetes Meetup said that was what you should do. However, in real life, the big problem with this is this philosophy was built by companies like Google, which is awesome. I love Google, I love Meta, I love all those companies. However, they have a different business model than the rest of us. They are selling, the product is the users, and the real customers is the ad network, okay? So if you test and prod and you do A/B testing, you can say, 10% of my traffic failed. Who cares? My customers are still happy because the ads got served, right? You see, so it's a different kind of philosophy, right? Now, if you work at a bank, you have a totally different philosophy. Your philosophy at a bank is, under no circumstances can anything break ever, right? So that's why test and prod, a lot of people are getting mixed up because they're trying to do test and prod, but you just can't do it unless you have those factors, right? Or a job. Okay. There's another problem with it too, which is that if you're testing and prod, you're only going to be able to replicate the traffic that is running through your systems right now. So let's say you go and you push a new deployment or whatever. You're only going to get whatever tests they have. Now, again, if you're Twitter, that's not a problem because your traffic is incredibly homogeneous. Everything looks the same. It's just people doing gets. Occasional post, get. You can go and test with that. That's not how most apps work, though. Most apps have like a one big, I call it the pig in the python, right? You're trying to swallow this gigantic thing once, and it's a big transaction, moves through. That's how more like other apps work. Every transaction's different. There's all this stuff going on. So test and prod, I didn't have the heart to do it because they're one of our partners, but I was going to make an image of a dog eating an enormous pile of data, but money seemed better. If anybody knows the reference. All right, so if you're a test and prod, you enjoy this photo. It is a collection of mats trying to diagnose a problem in production in a war room. So test and prod merely takes the problem off your desktop and makes it your team's problem. Fantastic. Okay, next choice, mirroring. Yeah, that's gonna solve it. We're gonna mirror. Yeah, that's gonna be it. Okay, cool. So now we're not dangerous because we're not directly in prod, right? Like you're not doing A/B tests. So you solved one of the problems. Your users are no longer your crash test dummies. Sounds good. Okay, cool. Now X, because Twitter's not Twitter anymore, it's X. So they say this is the new way, you should do this. Okay, cool, let's do it. All right, cool. Good news is you don't have to write test cases. There's no test case to manage. No, it is real data, so that's good. You've definitely stepped up in the world. Problem is you have another set of problems, which are even worse. You have PII, right? PCI compliance, all this other stuff. Second thing is timing is everything, as with so many things in life. You still have that problem of whatever the users are doing at that moment is the only thing you're going to test. Not very useful. Number three is networking is super hard and very confusing, especially for developers and mere mortals. Actually, I don't know, Joe, I don't want to put you on the spot, but you built such a system to test traffic mirroring. What seems easy for Joe may not be easy for the rest of us. I don't know if you want to talk about it for a second, but
Yeah, no, there's in the past working in an area where we had lots of crazy network stuff going on, and in this problem space before cool tools like this existed, we kind of built our own in-house to be able to mirror traffic or shift traffic in a way that would not be impactful to production, because making phone calls and sending text messages is kind of an important thing when you have 911 calls and things like that going on.
I think there was a company that had a problem with this recently, AT&T, I believe, took down the entire Southeast. Anyway, or no, nationwide, their whole network was down.
Networking is hard.
But fortunately, the problem is almost always DNS. For those of you just starting your career, remember that, it's always DNS. So I arrived at this prompt of a cartoon roadrunner pulling levers while eating birthday cake through a variety of other prompts that led me to this. Basically, what it was saying is, you're doing something crazy, so stop. So that's the result of that prompt. Okay, so in order to solve these problems, we have to introduce the idea of persistence, which means that we have to become decoupled from time, which means we've got to store everything somewhere, right? We have to be able to scrub it if it has PII, although I don't know if you should be taking the simplistic approach. If you're doing PII, we have a company that solves that, right? If you got really heavy duty stuff, there's a company for that. But if you need to scrub it, okay, you got it sitting somewhere, so you can run JQ over it. You can do all these different things with it, right? So cool. By the way, Twitter, Facebook, and Google landed on this. You can see it in their blog post. They evolved to where they basically got to traffic replay. So the whole idea is record and prod, store it somewhere. Don't just make it a networking problem. Store it somewhere, and then replay in staging, development environment, or whatever. It's great. It acts like a time machine. Okay, now, ideally, because my company does this for a living, there are no problems, and that's the end of the presentation. You should call us. In real life, there are a few other things that you need to take into account. First is, you can generate a lot of data. Store this. You got to store it somewhere. Second thing is, reauthorization is still an issue. I'll talk about some ways to solve that on the cheap, right? And then if you need the heavy duty thing, there's stuff for that. And then new API versions break this every time. So, you can use it for regression testing, that telling your app team it's their problem, not your problem. You can do it for that. But the moment somebody adds a column to a database, you have to get into all this data transformation stuff, okay? So that's some of the downsides of it, okay? So I'll pause for a second. Anybody have questions? Anybody done this before and want to challenge what I'm talking about here? These three modes. Huh? I love a challenge on this one. Yes, please.
So, not the challenge, but the question. You're replaying network traffic, right? This is all that network traffic.
That's what we're going to do here. Yeah. Mm-hmm. Yeah, we're going to record it straight off the network using a format called PCAP, which is the same thing Wireshark uses, if you've used Wireshark. And then we're going to do some really unpleasant stuff, some scripts that I wrote to kind of turn it into curls. Basically. Yeah, it's really awful. Great. Ken knows what I'm talking about. He loves this. What's that?
I said, what did those network packets ever do to you?
A lot. I think we can all agree the network packets have it coming. Okay, moving along. All right, so here, I'm gonna show you my professional demo architecture as made by AI, and that is a real thing. So you too, you too can make network diagrams, and apparently AI is gonna replace us all, right? Because it comes up with stuff like this. Okay, so here's a real network diagram, okay? How are we gonna do it? All right, the capture part turns out to be the hard part, okay? Now, it used to be this was downright impossible, okay? So I come from the monitoring space or observability space. Anybody heard of Datadog, New Relic, Observe is a company I worked at, or those monitoring companies? Okay, cool. So I worked in that space, so did one of my, so did some of my co-founders here. I worked in that space for about 20 years. Super hard problem, capturing production. So there's two ways that you observe an application that makes sense. One is like to improve your visibility. One is you get deeper information than you ever had before. So that's where the PCAPs come in. We're gonna look at some network traffic. That's a deep visibility. The other thing is you use AI to make sense of the data, which is a different problem. But we're gonna focus on the capturing part, and we're gonna do it from production. Now, there are two ways to do that. Capture pod traffic unobtrusively. Actually, I'm probably gonna get corrected by somebody. There's probably more, but there's two I know about, okay? So way number one is the standard way, which is Envoy. It's current standard, okay? So everybody here, you ever heard the term sidecar? Kubernetes, right? Okay, cool. So it's a specialized kind of sidecar. It's a sidecar that has a transparent proxy that basically fakes out the pod by messing with its networking. It's called IP tables. But it goes and messes with the network and it reroutes it to a listener, what's called a proxy, the transparent proxy. So it lives inside of a sidecar that sits on top of your container, okay? So Kubernetes, it's become very common to put sidecars on top. You heard Joe point a kubectl sidecar. This is a very common pattern. It's the current standard in the sense that Envoy uses it, Linkerd uses it, all the big service meshes, everybody's doing heavy duty networking, you're gonna find some sidecars. Okay, it's cool. That's good. However, there's some downsides to it. Sidecars can introduce latency. Sidecars have to have the SSL keys in order to decode the traffic. There's some downsides to this, okay? So there's a new kind of technology that has been on the scene for about 5 years. Actually, it's been on the scene for about 20 years, but it's been popularized in about the last 5. It's called Extended Berkeley Packet Filters, eBPF. Now, tell your boss you know all about eBPF, you're instantly gonna get a raise. Maybe not quite that easy, but it's super forward-leaning technology, okay? And what it basically means is we are not going to try to capture it on the network anymore. Instead, we're going to look into the Linux kernel at just the right point to grab information. One such point is the SSL library, where everything gets decrypted from the network. So you can go and you can ask Linux carefully and with the correct security constraints. You can go and ask Linux, hand me everything going through the network stack already decrypted. So this technology has existed forever, but it's just now gotten like kind of mature enough to where you can use it. This is the promised land of monitoring in a way, because it allows you to get very deep visibility into what's happening without super high overhead. Okay, overhead meaning introducing latency, memory, CPU, et cetera. Okay, now the core eBPF technology allows these things. Now what you'll find from some of the monitoring vendors, some people just do not do things right. And they will have horrible ideas, like they will say, we have an eBPF collector. I'm not gonna name names, but you'll find out immediately if you install one in your cluster, believe me. Just if your alerts start going off. Some of them eat like 40 gigs of memory. There's all this crazy stuff, but that people have done to this technology. But the core technology just means inserting those little listeners into the Linux kernel and doing so with very, very low overhead, okay? So eBPF is the new thing, is where everybody's gonna go. So my evidence for stating that is that Envoy has just introduced an eBPF. They've started with the Envoy, or maybe it's Istio, sorry. Istio has released an eBPF collector. It's not ready yet, but eventually it may replace Envoy. Envoy is kind of the routing engine inside of the service mesh called Istio. Okay, it's like a routing engine. It's more than just Istio, but people know it from Istio. So, okay, so that's super cool. That's eBPF, and we already talked about the sidecar. Any questions on that just yet? Anybody have any questions on this? Nobody wants to do some packet analysis? All right, we're ready to have some fun. Okay, let's do it. Okay, this is my checklist for release at speed scale. I hope this inspires confidence in everyone.
Now, will your credit card information be in the replay? Or
What's that?
will your credit card information be in your replay, your packets?
No, my ATM pin is though. Yeah. things.
Okay.
Actually, Nate's is in there as well. I think his is probably a lot more useful than mine. So
Higher credit limit over there?
it's Nate up there. Yeah.
Oh, Nate up there, okay.
Yeah, don't go in Ken's. That won't help.
I'm kidding.
I'm kidding. Yeah, you're gonna have to get in line. You gotta get in line.
All right, there might be some pizza left over for you later that
All right, so let's start showing some of the stuff off. Okay, cool. So one of the things I love. Okay, we're gonna use an open source project.
Make it bigger.
Yeah. Sorry. Okay. Let's.
Yeah, I can definitely read that.
Okay. How about now?
Nope.
Nope. Okay. Let's switch the game up a little bit here. How about now?
Yes.
That's as big as it gets. Okay. All right, so there's a really cool project I recommend everybody take a look at some point. If you want to try this technology out, it's called KubeShark. And the name implies it all. They basically are Wireshark for Kubernetes. Super cool. It uses something called eBPF. Now we're going to talk a little bit about the downsides of eBPF, but we're gonna get to them like piece by piece. Okay, so KubeShark. That's installation if you use a Mac. Okay, that's it. I've already got it installed, so we won't do that. Now, I recommend always installing things first in production before you bring them back and test. That way you know they'll work. Okay? So KubeShark is just such a technology, you should definitely just run this straight against your production clusters. Now, no one in this room is stupid enough to do such a thing, but I have some notes from someone who attempted it and learned some things. I'm not going to name those people, but if you turn this on in production, the eBPF part will go great. It will record all your stuff. However, your cluster will eventually become non-responsive if you leave it on too long. Okay, so that has happened to me several times with this thing. So it's a great open source project. It's great for trying out the technology. It's not like you got to be careful. Don't leave it on in production. That's all I'm gonna say. You can leave it on for a little while, and then it will eventually something backs up and it gets stopped. So it's new tech. Okay, but there are two ways to run it, and I love this about it. You say KubeShark tap. So way number one is just KubeShark tap. Don't know why this is broken. It is broken for some reason. But normally what happens is you run this. It just broke literally 5 seconds ago. I don't know why. It was working a minute ago. So again, new tech. But you take KubeShark tap and then you get something awesome happens. Okay? At least I think so. What happens is, and it's going to work. Okay, cool. Oh. That's what happens. Okay, so, all right, let's walk through what it's doing. Okay, so I ran this command called KubeShark tap. And what this did is, and it's kind of amazing, it installed a daemon set into my cluster. Okay? Now, it's using a daemon set because for this eBPF thing to work, it has to be installed one per node. So daemon set's the right choice for that. So you're not going to see it in your deployments or whatever. You will see it on all kinds of cool, crazy stuff right underneath the scenes. The moment you hit KubeShark tap, it immediately sees all the pods that are running in your cluster, which is super cool if you're not in production. So you get this long list of pods and other stuff right here. This is actually what's running in my Minikube, so it's like super neat. What you get from at the end of it is it opens up a web browser, and let me know if I need to make this bigger. See what happens here. Work? Oh, it's gonna work. Okay, cool. Yeah, all right. So when you go and you link to this port, if it's running in your cluster, you'll need to open a port forward. Everybody know what a port forward is with kubectl? Okay, all right. If anybody doesn't know, it just basically means poking a hole into the cluster so you can basically open a network connection to the cluster, okay, in a very specific way. So what we get is this user interface, which has a few cool features. First thing, shows you a network map. I didn't configure this. It just happened. That's really cool, right? And I don't know why DNS isn't red, but it should be. So core DNS, all that stuff, right? I can see all of the Kube API calls. I mean, it shows everything that you could ever want, right? It even shows here, I'm gonna run some demo traffic, okay? Let's see, I'm just gonna run a few little things. Here we go. Okay, this little demo app that I've been using. Yeah, no problem. So
since you're basically the way you're running it, you're required to have basically cluster admin on the cluster itself. Is if you did not have cluster admin, could you create like cluster roles so that if a user or service account had permissions, they could use this tool? Like, could you run the daemon set as being as dormant, and then only when someone invokes into it, it would work?
I'm not sure. It requires, like you said, cluster access in the sense that, it basically requires the most privileged access you can get to your cluster. I don't know how you turn it on and off in that sense. You can make cluster roles. I don't know enough about the dormant set.
Okay, I mean, I'm just
If
wondering.
somebody else does,
because-
please feel free to answer.
It requires the ability to run privileged pods on the nodes, which is,
The same thing.
yeah.
Okay, you're in the same
Yeah.
spot. Yep, okay. Well, I guess that's your answer. So eBPF, now, issue number one is, most eBPF systems are not ready yet for mass volume, which is, so jokes aside, that's what I'm really saying about the production thing, is that if you run it, it just gets backed up and eventually it breaks the cluster, because it's just, the technology is not quite mature. It's not a flaw in eBPF, it's a flaw in the KubeShark open source tool, but nonetheless, that's like issue number one. Issue number two is what he was saying, is that the sidecar approach to recording traffic doesn't require the same privilege level as installing an eBPF collector, because essentially eBPF has the highest privileges because it can see everything happening in your cluster, down to the most minute thing. So that's one of the downsides of eBPF too, which is what you're pointing out here. So this is a quick and simple demo. There are other ways to get more of that done. So okay, so what I'm going to do here is I'm going to run just some demo traffic, right? And what I'm going to see here is new nodes appearing as we go along. It's slick. It's cool. Just I got to shut it off after half an hour. It's really cool when it's working. But no, you can see how you could do this, right? Because you just want to get the little recording and take
Protected
it.
at 32 minutes, though,
What's that?
right? But the thing is, it takes 45 minutes for your problem to happen.
You're thinking too hard about it. Yeah, no, I know. No, so I mean, jokes aside, we make a commercial tool that is like production ready for this stuff. So I'm joking around about it or whatever, but you can leave this long enough to grab some traffic and just make some quick tests out of it. And that's what I'm doing here.
Okay.
This is not the kind of thing you leave on all the time, okay, to be clear. But I want to show that because I think it's super cool. And so my demo app, you can't really see it very well here, but my demo app, you can zoom in. My demo app is now showing up in here, and then it has these quick little plus buttons, like cool plus buttons that say, I just don't want to see this traffic from this pod, or whatever. So it's kind of neat. You can kind of slice and dice it. It has a filtering system. It's pretty simple, but it's a lot of what you need. Okay, now for our purposes here, we're going to go and make a little CI test that goes and tests and makes sure the app works right. Okay, on time. How much time do I have left? Okay. All right. So I got all kinds of stuff here, and I got to kind of filter it myself by hand here. But you can go and you can use this filter bar to say things like, I only want HTTP traffic. And now it's only showing you HTTP traffic, and you can see the URLs and endpoints here. So you can kind of play these games. So it's kind of cool, just for diagnosis. All right, but I'm not here for diagnosis. I'm here to make my app team's life hard. So next thing I want to do is I'm going to drill into an individual API call. So what I'm after is I want a set of APIs that are reproducible that'll give me a sanity check on my app. So I'm just going to go and pick some randomly. This is a demo app. It calls SpaceX. I don't know why. It's just the demo app we have. It has some headers here, authorization. If you've ever tried to debug an app in production, you know how valuable this is, just being able to look into the data like this, exactly what calls, pretty cool. It has the responses too. It has all the different HTTP headers, the bodies, pairings, all this stuff. I don't know how well you can read that, but that's bodies. Let me see if I can make the bigger. Their UI gets a little bit messed up when it gets too big, but maybe you can read that, hopefully, enough. I don't know. I guess I can get a little bit bigger. About that. Okay. Okay, so what am I going to do? All right, now, KubeShark is open source. It is just become commercial after a point. You have to pay after a certain point. But it has one really cool thing if you're willing to put in a little effort. It can store traffic into S3 or GCP. So what I'm going to do, I'm not going to show it because it takes a while, but you can find it. I'll show you the docs link or whatever. You basically go, and every time an API call comes in, KubeShark has a callback mechanism. So it'll go and it'll call a little JavaScript for you, basically. And one of the things it allows you to do is to store that in S3. So what I did to make this is I just put it in one little call that said, every time an API call comes in, I want you to put it into an S3 bucket, and I want you to append it into like a JSON file, right? Like a new, one line per request, okay? So the way you can do that yourself, it requires a little bit of doing, right? I did it, and I got some responses. But essentially what I end up with is this JSON metadata for this call, which includes every detail necessary to reproduce the call. So if you look over here, and again, it's kind of hard to read when I'll chunk it like this, but the metadata you can go through here, and I don't know if I can find it here, but it has things like, here's my app name, here's, let me try to hunt it down. Yeah, there's my pod, you can see my pods down here. You can see, let me see if I can find it this way. It's just path. Health Z. Okay, so I chose a health check, I guess, or, well, no, maybe I didn't. Never mind. So here's the past segments here. You can actually get all this data to create the URL. And so it's pretty easy to go and make a script that will comb all that information in S3 and turn it into a bunch of curl statements. So if you are, this takes a little bit of time, but it's no big deal. And I have most of it up on GitHub, which I'll post at the end here. What you get out of all this, once you have some CubeShark stuff, is you make a little script, and what I do is turn that into, don't worry, I'm gonna make it big in a second. And what I do is turn it into a YAML and with a bunch of curls. Yeah, you're laughing, right? It's funny. It is funny. It's ridiculous looking. How many broken apps have I found like this? And everybody's laughing, all the app teams laughing, and the Go programmers like, I'm so smart, I know Go. And the JavaScript guy's like, and he's like, my app works so well, and then I run my stupid curl script, and then it breaks. And then everybody has a good laugh, and by everybody I mean me. So that's what we do here. But okay, so what I did is I wrote just a little script, and it's very straightforward. You can find it on GitHub. And it just turns them all into, makes a YAML out of it, and this allows me to run this periodically using normal Kubernetes mechanisms. So what I normally do is put this into a cron job, which I'll actually show you. It's a really simple format. Everybody who's deep on Kubernetes is laughing right now because they know how to do all this. For the rest of us, this is pretty straightforward. Oh yeah, I forgot to mention, one other thing I do with these usually is turn them into synthetics for production. So who uses Puppeteer? Anybody? Okay, so yeah, so like Puppeteer is kind of how you write these synthetic scripts, and they look really great when you write them, and then they're out of date in a couple weeks because they break because the app changes or something, but you always start with that, everybody does that. So I take a little bit different approach, which is just I run the curls against the API endpoints, and I do that in production too, and you'll notice that staging and production look the same way, and that's through AI. No, it's a joke. It's the same screenshot. It's the exact same script. You use the same script to do your test and QA as you do in production. So then you get a synthetic, you turn it into a GitHub action, for instance. So then basically every time your developers try to push a new build, you have them run headlong into your GitHub action here that runs your curl job. You make sure they didn't introduce a regression because you actually introduced the production traffic, and then it fails, and then everybody knows. So I'm not going to do, the replay I kind of already did by playing this. You can see in our cluster, there is a return status on this job I just ran. That's what I've got highlighted here. That's the job with all the curl statements I just ran. There's a return status that will turn into error if it fails. So then we can alert off that. Now we have this is a very, very cheap way of writing a bunch of tests. So, okay, so I went through that quick because it is late. And you can kind of fill in the blanks on the rest of it. Any questions on that piece? I have a couple closing things here. Make sense? Okay. Your app developers are going to laugh at you with your silly curls too, pretty soon. That work. Okay, so inevitably when I talk about this kind of stuff, there is some very smart person in the room who says, but Matt, wait, you haven't thought this through, there's all these problems. Yeah, I know there's all these problems with it. That's why I started a company that solves these, that's why we started a company to solve this thing. There's a lot of other stuff going on. You can still get a lot of value just looking at the GitHub and putting in your own basic curls. I'll tell you a few examples of things that are going to break on you. Don't use the same curl statements for more than 7 days. Why? Because the default for a lot of Java apps when they do the Spring Boot demo is they have their JWTs expire after 7 days. No one ever changes it. So anyway, so like stuff like that, your JWTs are going to expire, right? So that is something, these are like limited lifespans. So you're going to have to create automation around these things to put them in. You're also going to get into data privacy. You get into what about backend systems? For instance, if like a lot of transactions, when you're talking gets, it's really easy. You notice my presentation is all about gets. The moment you do something like a post, there's some database that changes, and then you end up in commercial product land at that point, right? Like you've outgrown this kind of thing at that point. Data privacy, security, checking payloads. So does anybody want to tell me, any smart person want to tell me all the things I missed that are busted? Because this is where you stand up and tell me. No? Anybody know anything else? All right. I'm looking at YouTube because you've tried it before. All right. So, okay. So yeah, this is my totally not a stolen marketing slide. So there's a solution to all this stuff. I will skip over that, because my co-presenter is not here. I had a co-presenter for the rest of this. So anyway, so if you're interested in this kind of thing, I'm happy to talk about it. I will post the GitHub link. I'll give it to Joe, where you can go get the little scripts and play around with it, try it out yourself. KubeShark, Cube. Does anybody know kubectx, that command? Mm-hmm. Change your kube context. Very important when you're running against production. You want to kubectx something else then run KubeShark. And then you're good to go. If you're interested in the commercial side, I'll make one little plug. My company, our company, we're all in the room here, the founders of the company, SpeedScale, we solve this problem on a commercial level, totally, set up, so we're happy to talk to you about that, but this is how we get started. So, anything else? Questions?
When you say we solve this, what is specific, like, what?
Oh, you mean my company?
Yeah.
So SpeedScale solves these problems in, I'll go ahead and say this, let me go back here, and Nate, I don't know if you want to chime in. Nate is a better speaker than me, so he will probably say it better than me. So when you get to the commercial side of this thing, so we solve the problems of continuous reporting in production. We have schedules where we run things all the time. We do things like we automatically re-sign JWTs because we're smart enough to find where you put them, right, and go in and re-sign them using the Kubernetes secrets. There's all this fancy stuff that happens. We have we're all about AI now. This is actually why this is probably our last traffic replay, like straight traffic replay presentation. What we've done is we've taken so like the super hard problem of figuring out how to massage the data. We plug that into an AI. We auto-generate data using LLMs. There's all this fancy stuff that we do around that. So
So the meta thing is, it's just like KubeShark on steroids. KubeShark takes care of kind of the invocation side of things, but the things that end up holding you up after that are the data and the environments. And so SpeedScale takes care of the data and the environments as well by analyzing the traffic.
Okay.
it makes automatic service mocks. It orchestrates tests. It does all that stuff. So it's way beyond this, but it's this is the beginning of it. So yeah, thank you for the question. Anything else? All right. Well, hopefully that was a little entertaining and maybe a little informative. So, have a great night. Thank you.
This is a question about the CLI. I asked Alex, it's bubble tea and then some custom work on it, so, yeah. I thought you meant the app, the web app. I'm not on the chat anymore, so thank you.
Okay, everybody, on the call, thank you, and thank you again to both of our speakers, Jen and Matt. Great content, thank you for sharing with our communities. As usual, we're always looking for speakers for our next meetups, so if you have a topic that you're excited about and you want to share with the community, please reach out, let me know. If you have a topic that you're curious about and you want to know more about, please let me know, and we'll try to track down speakers for that. Outside of that, hang around a little bit for some social time, and thank you again for coming.
Thank you.
Thanks, Joe.
I was going to ask about Dagger.